Recommender systems. There are two basic approaches to recommending. Well, this is not rocket science. This is age-old thing. One is collaborative filtering, also known as social filtering, and then content-based. Content-based is something we all know in terms of what we want to buy is content that is thrown to us. Systems for recommending items, I'll just pick up a few examples. It could be books, movies, CDs, web pages, news groups. It could be anything. And these days, it's all about Netflix and Amazon Prime and all of it, right? So I'll take some example from there. Based upon the preferences and the preferences that of the end user. You and me are all end users for all this. So we are using a lot of recommender systems, knowingly, unknowingly, but after this, you will exactly know how it gets implemented. So many websites provide recommendations to all of us, which we all know: Amazon, Netflix, Pandora, Amazon Prime, Flipkart, all of them. Recommenders have been shown to substantially increase sales at online stores. Okay, this is some study. Wonderful, fine. So how do we actually start implementing the recommendation or a recommender system? Recommenders are instances of personalization software. There is personalization. We have moved away from customization to personalization in the last decade or so. Personalization concepts adapting to what is it? What is personalization means? To individual needs, interests, and preferences. So basically, we are going back to consumer behavior, components of consumer behavior, components of consumer attributes, which is needs, interests, and preferences, which also includes, in the sense, the recommender system or personalization includes recommending, filtering, and predicting. Oh, wow. I'm not only doing recommending, but I'm doing filtering also for the user, which is good. I don't have to go through thousands and thousands of listing for me to pick as to what I should be looking at, right? So, and I watched something initially on Amazon Prime. For the first and the second time, there couldn't be any recommendation, but from the third time, I would start getting some recommendation. How has this happened? It would pick up from various different algorithms and artificial intelligence system that is working in the back end. So we'll get into the details, but from a business perspective, it is viewed as part of the customer relationship management. Wow, wonderful. So my customer relationship management, it is getting automated at the back end. I don't need a person to actually be interacting with the customer or the consumer as of now, which is good, okay, but we need to look at machine learning and personalization as to how this gets built. Machine learning can allow learning a user model or profile of a particular user base. We spoke about data model, we spoke about the product model, we spoke about the user model in the previous presentation. So it picks up some sample interaction and rated examples. Somebody would ask you to rate the product. Somebody would ask you to rate their service, right? So depending on the rating that you give and depending on the feedback that somebody would have typed in, there could be some recommendation systems. For example, when you go on to the Play Store, you would download some of the apps only if the rating is 4.5 and above. Only those apps are trustworthy if the rating is 4 and above, right? All of these systems need to be built at the back end using some of the basic principles like what we are just speaking about, right? So this model or profile can be used to recommend items, filter the information, and also predict the behavior of the user. Okay, wonderful. Now let's get to the basics. A personalized online store, right? Now this we keep seeing frequently bought together. Now, when I go to buy something, there is a recommendation saying that when you buy this, many of the users would also want to buy this. So frequently bought together is depending on some of the learning the system has done, looking at the pattern of the buyers. If majority of the buyers have the same pattern, this recommendation would come to you if you have bought one of those items, saying that frequently bought together, right? Okay, now something beyond that. customers who bought this item also bought. Oh wow, there is some recommendation coming in, some filtering also coming in based on your preference as well as the learning from similar preferences of others. It could be product based or it could be user based or a combination of both. Okay, now it is getting complicated. Let's go together. Right now, a personalized online store, what they say, what other items do customers buy after viewing this item? There is this recommendation and filtering, right? So data science, data mining. Now I'm looking for something. I just want to know about data mining, right? So along with data mining, it would also recommend whether I want to buy this or not. So what is the recommender problem? Look at this. A good recommender and the challenges that it faces. And when we talk about a recommender, it's our program basically, right? So programming titles to a software engineer and baby toys to a new mother. A good recommender, right? So programming tiles. Now I know that I'm a software engineer. I would not be shown something about a mechanical engineering product. I would be shown something that would interest me while I do the search. And then, of course, baby toys to a new mother. Of course. Now, a new mother who's come online would be definitely looking at something to be used for the baby, right? And don't recommend items user already know or would find anyway. So that is something which I need to eliminate. While I'm building an algorithm, I need to keep all of these aspects in mind. Expand user's taste without offending or annoying him or her. There's a classic example. This is one of my manager used to tell me, and he was a Sardar, and one of the things that really annoyed him when he went into a mall wherein there was a recommender system that was that was put in place, and he laughed it out, of course, but it could have offended somebody else if you recommend a shaving cream to a Sardar. Right? It's a wrong recommendation. A simple example which can be hard-hitting is, it can't be hard-hitting than this. I never use a razor. I never use a shaving cream or a shaving foam. So the recommendation, if it comes to him, what would that person do? He would just get annoyed and he would stop using that system going forward. Very, very important, especially in India, wherein we talk about multicultural, multilinguistic, multi-religion, multi so many things. It becomes very, very important that my recommender system doesn't offend anybody's beliefs, faith, religion, gender, affiliations, whatever. So if you could have a recommender system which can work in India, it could work anywhere in the world. So the challenges are, I did mention the challenges. Huge amount of data, tens of millions of customers' data that is available, which you need to siphon off and bring something in. So a recommender system should adhere to the dialogue is, tell me something I don't know. मला काय माहित नाही ते सांग ना भाऊ. Right? So that is what my recommender system should be. So for doing that, I need to have the recommendation engine built up, and it would have all the various different components of web scraping, customer data analytics, customer behavior analytics, consumer analytics, product analysis, the models, and of course the algorithm feature that I would bring in to collaborative filter or focusing on something else. So let me get into this. Two most widely used traditional algorithms are user-based collaborative filtering and cluster models. Content-based filtering or collaborative filtering. Right? Content-based would be on the product and collaborative would be from user to user. So in content-based, it would be product and the recommendation in terms of consumers bought this along, and they would also be looking at some other product kind of a recommendation. But collaborative filtering would be like the book that you have read, your friend also has read it, or your friend also has bought it. So that goes to the next level of personalization. So this is something that we know of. Engine generates 35% of companies' revenue as long as McKinsey's 2013 research, Amazon's recommendation engine itself generates 35% of companies' revenue. Now look at that. Now the same thing holds good for mostly my Netflix and some of the OTT platforms as well, I suppose. Right now, recommender system. Few more slides and I'm done with this. It talks about the item features, user features, which is what we talk about, the user item matrix. So common types of data that we would look at is search for the purchase data, the past purchase history of the purchaser for doing some consumer analytics, consumer data analytics, and then look at some ratings and some comments overall, and then provide some recommendations that can go along with what is being presented. So my data, which is mainly of the user and the item, comes into my recommendation system, and I would put in some content-based collaborative filtering to come up with top pop, which means to say that the most popular thing comes up, right? This is completely non-personalized methods wherein the most popular thing comes up, which I may like or I may not like. So for example, the most popular movie comes up as a recommendation being watched by 10 million users, which is watched and liked by 10 million viewers. Something of that kind would come up. I may not be interested. Now I need to get to the next level of probably being personalized. Now, to come to a personalized, I need to not only look at item features and user features, not just restricting it to user item matrix. I need to go beyond. But first, let's understand the content-based filtering that happens. So, for example, if the reader, the user is reading an article, similar articles get popped up. The classic example is Google Scholar, wherein it gives you, may not give the exact ones, it may say similar ones, right? So, which is mainly in terms of the content based, again using collaborative filtering, but this is a little bit hybrid, wherein I'm combining not just the product, but I'm combining the user also. So that leads to the next thing. If I have combined the item and I've combined the user, I'm doing item filtering. Why can't I do user filtering as well? Oh yes, I can. So collaborative filtering of the next level would be not just on the item, but also on the user. So user preferences, item preferences, and then the recommendation. So it becomes a multi-matrix approach when we talk about the collaborative filtering. Now, this is where it all comes. Item I have done, user I have done, user item also I have done. So in my data, I have a matrix of item features, user features, user item features. Now, when I bring about the combination of these three different elements from three different data sets, I would do content-based collaborative filtering of all of this put together to bring about some accurate recommendation systems depending on the various different factors that are there on the item and of the user, and provide some recommendation in terms of accuracy to a large extent. When I say accuracy, when you recommend it to me, not necessarily I will agree to it. So to the tune of probably 70-80% accuracy, user satisfaction, diversity, novelty, if I want to look at something different, which is novelty and stuff like that. And that would mean that I have implemented a recommendation system using a lot of algorithms on my machine learning, provided with a lot of data, which will self-learn when I have artificial systems incorporated, which would work in tandem, in collaboration with my algorithm, which would become unsupervised system going forward.